Let's do a harder L'Hopital's problem. This one is nice because applying the rule once is not enough. Sometimes you have to apply it multiple times. This type of question will most likely be on the AP exam or your final for college, anything like that. So let's get right into it. So we have the limit as x approaches 0 of e to the x minus 1 minus x over x squared. So first things first is let's just plug in 0, see if it magically works out. Maybe it might. We never know. So we get e to the 0 minus 1 minus 0 over 0 squared. E to the 0 is 1, so we get 0 over 0, which is indeterminate form. So let's use L'Hopital. And I always kind of draw an arrow like this just to tell the grader, here, look, I have, tried it, didn't work. Now let me use L'Hopital's rule down here so I can immediately take the derivative. So let's take the derivative of the top of e to the x minus 1 minus x. And that is just equal to, so derivative of e to the x is just e to the x. Derivative of minus 1 is 0. And derivative of x is 1. So we just get minus 1. And that is your top. Now let's do bottom. So d dx of x squared is just 2x. So now let's rewrite that. So we have e to the x minus 1 over 2x, limit as x approaches 0. So now let's try this. So we have e to the 0 minus 1 over 2 times 0. E to the 0 is 1, so we get 0 over 0. That is also indeterminate form, which means we just solve L'Hopital again. And sometimes you have to solve L'Hopital multiple times. The beauty of L'Hopital is that eventually you, taking derivatives over and over and over again, you will get rid of your potential to get an indeterminate form. You will get rid of these variables. So let's take the derivative of the top. So derivative of e to the x minus 1. The derivative of e to the x is just e to the x. Derivative of 1 is 0. Then we have bottom derivative of 2x is just equal to 2. Now let's rewrite your new equation. So you have limit as x approaches 0 of e to the x over 2. Plug it in. So you have e to the 0 over 2. E to 0 is just 1. So the answer is 1/2. And that is your final answer. So this is a great reminder that after using L'Hopital's rule once, you have to check the limit again because you may get another indeterminate form, how we did here. So sometimes taking it one time isn't enough and you need to take it more than one time, but always, always, always check the limit after every single time. Hopefully that makes sense.